And now we will dig into the business models with Stefan here, who will introduce his thesis to us. So please, welcome.
Thank you. So I thought we can rise again. Rise? All rise. Ah. So because I want to continue on Mr. Lycken's experiment. I want to make an empirical observation. So please, everybody, sit who have heard about ERS and know what it is. Don? No. So this is the first time this happens to me. I always used to ask this question. Who knows about ERS? And this is the first time this happened. So it's a great pleasure to be here. Where we go to niche and mass markets. So the findings show that if I analyze this from different actors in the pilot project, for example, the slide-in project, as you saw the truck, you can see there is, they test an alternative technology, and there is no discussion about new business models. So we saw that there are incumbent business models that won't work, but there is also only a link between the policymakers and the subsistence suppliers. We give you money for doing this kind of sustainable technology, and we develop this, maybe, hopefully, to create a market. In demonstration project, as in Gävle and LA, then, and now Germany, then you bring in the system users. So you test the whole system, and also the perception of the users, and now business models are starting to develop here. But there is still no commitment between policymakers and users. Users are not committing that they should use it. And in the last project, then, deployment project, here to have this happen, you need to have the interaction then between policymakers, different types of subsistence suppliers, and system users. And I think this was then what was missing in the LA case. A clear commitment from users to policymakers and vice versa. So the findings show that business models aren't really there yet, and they are, you can perceive them in different types of ways.
Established some promising routes for first commercial ERS applications in Germany. And we established an approach where we can associate the suitability in parts to the goods type. But we have to do further research on this. And what is very clear from the results is that for an economic break, even in the first applications, we will need some incentives for ERS operators, most likely, at least considering the German boundary conditions. Of course, we need a strong public commitment to the infrastructure build-up. And in this respect, I can only stress what Stefan in his excellent keynote said. It is really about commitment and reliability for all stakeholders.
So what we have been looking into is mainly three things. And that is the function of the system. How well does it work? Could it deliver power and so on? Safety critical issues. Is it safe for some person to use the system, or pedestrians or whatever? And then also we have been looking into EMC and sound from the system. And I will look into different parts here.
Solutions will depend on business logic, weight, cost, regulation, taxes, and yes, sure, that's what we talk about. There are several techniques, will be several techniques. We're still filling up cars with diesel and petrol. There is no legal demand on just one source, so things will change. Very often there will be combinations. Some implementations will be very suitable for shuttles. You will tailor-made drivetrains and trucks and stuff like that. One thing which is very important is that if you don't bring technology to use, it's of no value. Thought about that? We have a pay and pray economy. You know how it works? You take taxpayers' money, about €1 billion, and then you throw it into research and say, yes, may it become an Ericsson. No, it didn't work. Shit. Oh, we try again. And this kind of doesn't work. So deployment. How do you get the shit out on the road? How do you start using it? How do you get interested customers buying your product? But this is not really what we're testing. This is what we're testing. This is what hits you when you go out with a truck in reality. It's snow, it's ice, and it's terrible.
So these are all the sophisticated measures that we already take in our traffic control center, and this is the surrounding for our ELISA test track in terms of traffic management. But this is only the one side.
I was just wondering here, you have of course tried different ways of doing tenders and so on, but did this system fit into your ordinary legal system, or have you received exceptions?
Of course, we made an examination about that, because when starting it we did not know, but we found out that we have the legal framework to do so. It is equipment of the road. So we have a legal framework to have the planning process and the planning approval for this,
And we will show you a prototype of one of the conductive electric road solution we made here in Sweden, and it is based on an existing and well-proven solution in railways for tramway.
We were looking at testing out how could we use the APS from Alstom to have as a electric road system.
What is APS? APS is a system we have developed for tramway application to replace catenary system in city center, mainly for aesthetic reason. It is as efficient as a catenary system, but without wires and without poles.
Since in the last recent years, this whole e-mobility thing has also in Germany swept over to the automotive industry. We are also more and more participating in this field. And of course, there are many intersections between this whole e-highway system and electric railways, namely the DC power supply and also the transmission of the DC power.